Hai, halo semuanya. Ya, perkenalan nama saya Victor. Jadi saya join Tokopedia itu sekitar Oktober 2016, which is kayak baru 1,5 tahun lah ya. Tapi itu kayak udah feel like 5 years already, karena kita move so fast, doing a lot of things. So yeah, a very short time, feels like a very long time. Okay, let me just present it to you. So I'll be talking about our data warehouse journey, right? So in Tokopedia we have lots of data, right? So we do things very carefully, and we do things very quickly as well. So it's a mix of both, right? We need something fast, but we need something very accurate, right? So what we do here in Tokopedia, everything should be based on data, right? We do every decision is data different. So lots of pressure coming in for the analyst team who provide the data to the key decision makers, right? So who are we? So this is our Tokopedia data team. We consist of lots of different teams with different roles. So in Tokopedia we have 5 different roles, which is BI, data warehouse, data analyst, data engineers, and data scientists, which of each of them have different roles, scopes, and stuff. So I'm leading the BI, data warehouse, and analyst team. Okay. So how do I get here? So previously I was working with a business analytics company like a SaaS, which is for close to 3 years. And then I moved to rather a startup with a couple of friends, because we want to build something cool, right? And it turns out that the idea is good, but the execution might not be very good. But I learned from that, and then when I decided to move to Tokopedia, I just get all of my experience there and start building my own team here in Tokopedia. So when I initially joined Tokopedia, there's no BI team actually. So there's an analyst, there's analyst team, but no BI, right? So I built the team myself. So currently when I started, it was about 10 or 12 people in analysts. Now we are close to 50 plus. So it's quite of a long journey to get here, but it's just halfway to what we are going to achieve, right? Okay, when we're building our data warehouse, right? The first thing is, do we have enough resources, right? We are facing this kind of issue. So basically, all data, business users get data everywhere, right? Say they get data from their analysts, they get data from the finance, they get data from the BI dashboard and stuff. So how do we know which numbers is correct, right? Because some way the data might be comes from the same sources, but along the way there's some manipulation happens, right? We do some calculations and stuff. So how do we know which one is the right number, right? I think we all facing this issue, and no matter what our industry is, there's always at some point data is not consistent in each other. So how do we solve the issue initially, right? So this is like a brute force kind of approach. So we just put everything there. So people just want, we have a lot of data, so just put everything in one place, then see what happens, right? So this is happening actually in not only our company, I mean in a lot of matured industry, such as banking and stuff, they do the same kind of approach. But will it solve their problem? Might not, right? Because adding data to a single page can cause a lot of problem. So we end up with more issues. So first one is like scalability. So when we move to a single place, how do we maintain all this stuff, right? what do we do? What do we do when the storage is not big enough, right? So we scale out. What if the machine doesn't allow it, right? We hit the maximum capacity and stuff, right? And the second part is our data. So one of the most challenging part is actually integrating with our behavioral data. So we capture a lot of data, right? Every interactions you make with our with our applications, websites and stuff, we record all the data. Which button you click, right? Which websites are you coming from prior to visiting Tokopedia? So what are the information are in the button, right? Are you sending the product numbers, or you sending the customer profile and stuff, right? So this is like our data can be very, very granular, and it's very, very big, and it's moving very fast, right? So this web behavior data is actually our goal, where we can know our customer better, where we can know where they live, how much money are they spending, what kind of devices they uses. So this data is actually we're leveraging Google to capture all this stuff, right? So we use Google Analytics, but our transactional data is actually residing in traditional RDBMS kind of stuff, right? For example, we are using Postgres for transactional data. So how do we integrate those data together? And then the second part is our performance. So our user base grew 10 times during 2017 alone. So from this kind of 10 people querying the same table, now we are having like 100 different users are accessing the same table. And then from a single query that takes 5 minutes to complete, now it takes like 15 to 20 minutes. So how do we fix this kind of issue? So how do we get faster insight without sacrificing our user experience, right? And actually the last part is we have a lot of tools, so many tools. So when I first joined the company, basically the data is part of software engineers' problem, right? So they own the data, they produce the data, comes from the applications, they store the data in their transactional databases, and then when analysts want some information, they ask the software engineers to get it from them, from the software engineers. And then along the way, these requests are coming in very, very often, and it gets too complicated for them. And then they get access to the data. So when they get access to the data, they choose whatever tools they're comfortable with, right? Because nobody is managing it for them. So when they first interact with the data, they use some open source tools. But new analysts coming in, they're comfortable with programming languages, or they are comfortable with other open source tools. Then because it's open source, you don't need like clearance to install it in your machines. Then you get like, for example, you have like Pentaho to do ETLs, right? And some other analysts will have like talent to do it for them. So some other can have like doing Python and R on programming languages. So these problems actually arises. So the first thing I did was just to standardize all this stuff, right? We choose the right tool. It might not be one tool for all, but it should cover like 80% of them. So when I choose the tool, it's most about the functionality. So if you do a lot of transformations, then you need ETL tools, right? Instead of doing everything in programming languages. So, but if you need like flexibility, then you should choose programming languages. So And we come up with this kind of architecture in the first place. So this is simplified ones. So every applications will generate data, right? It can generate transactional data. It can generate logs data. It can generate, event-based data, right? So all this stuff, we are pushing it to the, transactional kind of database. It's like Postgres we're using initially for the data warehouse. So it works fine until it doesn't anymore, right? Everything should start small. So we built, when I first joined, I serve not all of the functions because I know it will be a hard thing to do, right? So we don't have the infrastructure, we don't have the team. So we start small and we start with the key business metrics. That's why in the business intelligence, we always start with the most important metrics, right? Which is money, right? For any company, the most important thing is money, right? So we start with anything related to money. We start collecting data about our transactions. We start collecting data about our customers. Where do they come from? How do we recognize our revenue and stuff, right? That's what we started. And then we moved to other, most important thing as well, which is the behavior data, right? So we start tracking our customer journey. So we start pulling the data about our traffic, our marketing funnels and stuff, right? And then we do visualization on top of it because data is data. It should get to our users eventually, right? And how do we communicate with them is through our multiple tools. Again, we use a lot of different tools initially. So some reports we send out through Google Sheets because it's free. Some reports we're sending through Excels because every company uses Excel, right? Some report we're sending through Google Data Studio because another free tool, right? Some reports we're sending through just what do you call it? Some kind of screenshots and stuff, right? Through your communication channels. So we're leveraging Tableau now so that we can centralize all these reports, all these dashboards, and how to interact with them, how to educate them to interact with the data, right? And then we decided that it's not enough, right? We know that the data is our gold mine. Then how do we mine it, right? So our answer to that is, always by leveraging big data, right? So, but what tool should we use, right? A lot of different companies offering the same kind of solutions to that. We can use on-premises like a Hadoop file system, right? We can set up our own data centers and stuff. But is that where we're going? I mean, do we have the capacity to build our own data centers, or do we have enough resources to manage all of it, right? And the second part is actually how do we scale without sacrificing our user experience, right? So we do a lot of researches, comparing each vendors and stuff. Every cloud providers we take into account, and how do we evaluate them is the most important thing, right? So our choice goes through BigQuery, and it's mainly because these four things, right? So it should cover our scalability issue because it's managed service. So every time you don't have to worry about storage, right? When your data hits like 10 terabytes or 100 terabytes or 1 petabyte, you don't have to worry about them. So Google takes care of it. You just have to pay them, right? That's the most important thing, okay? And the other thing is integration with our Google Analytics data. So the only data sources that can connect to Google Analytics data is actually BigQuery. So what kind of solutions works best with BigQuery is another BigQuery, right? So why do we have to move data? For example, if we use on-premises, right, on-premise solution, then we have to move the data from the cloud to on-premise to calculate them, right? Or we can calculate them on the cloud, but we have to have a data movement, right, from on-premise data. We have to move to the cloud to do the processing and stuff, and then write it back to the on-premise solution. Yeah, that's the kind of cost that we should take into account, data movement cost. So when we choose BigQuery, part of the main concerns is about the web behavior data, which like 90% the size of our total data, right? And then the second thing, the third one is actually performance, right? So we did some benchmarking and we come up with these numbers. Actually, we processed 500 gigabytes of data is within less than 4 minutes, which is very impressive for us. And it's like, well, why don't we have this solution? Because usually it takes like maybe 8 hours if your system is capable enough to do it. And when we find this, and then we start doing analysis more and more, right? We start being more productive with our analysis. We start discovering new information every day, because when you have this luxury, you can do more, right? Otherwise, if you wait like 4 hours to do your query or 1 hour, you will forget your thoughts process, right? If you I want to do this, and then I want to calculate this, and I want to calculate this, and then sum it all together and come up with a decision. If you have to do it like 1 hour to get the first information, another 30 minutes to get the second information, by the time you get the summarized information, it's already lunchtime. Then you will go to lunch, right? And this sugar rush coming in, and you get like very sleepy and stuff, and you start forgetting about your analysis. I mean, this kind of luxury is what triggers us the most, right? And then by leveraging this platform, we have a more unified data platform for us, right? Where we integrate our transactional data and web behavioral data. So our approach to that is, it's not as simple as just move everything to the cloud, right? So we start identifying what type of services that the Google Cloud Platform provides, and what types of solutions works best for us. Because to do data processing, lots of kind of solutions are there in the Google Cloud Platform. There's data flow, data prep. You can always spawn your own server and stuff to do it for you. And then, so our first approach is actually mimicking what we do right now with our data warehouse, right? So the first goal is should have your existing data in the cloud. That's the first goal, right? And then the second goal is to have it born in the cloud, right? For you guys to have new stuff in the cloud, it should be born in the cloud. Then it will be your second best, second approach to that. And the third one is actually, kill existing setups on your on-premise solutions. Then you can say that I'm fully in the cloud, right? You're up in the air. So we have two different data pipelines to get to our data to the cloud, which is the batch one and the streaming one. So actually, it's easier for us to do it on batch, right? Because you can control the environment and you can control the schedule and stuff on certain scheduled time, right? When you start doing streaming, it gets a lot of a lot more complicated because you worry about the downtime and stuff. You worry about the queuing system, right? Does it send you the this right information? Will it send you the same information you get in your transactional database, right? Currently we are still in development and exploring, but we found that when you start moving your data as a stream, it's easier for you to do analysis actually. You don't have to wait for the next schedule to come, and you get a lot of more confidence in your data, right? Because for sure you will have your data at this time of day, how many records are there, right? I think that's the second advantages when we start exploring the stream data, right? And the way we do streaming, so we explore a lot of options actually. So one thing is to have your stream pipelines in your application. So you will have two branches, one that is writing to your transactional data, one is that is writing to your landing database, right? That is I will call like a parallel stream data, right? One to your transactional data, one to your data lake setup, right? And what we found with that is there is a lot of inconsistencies in the data, right? So we always assume the transactional data is the right one, right? Because it's what you use for your applications. And then when the pipeline breaks, you start losing data. And some options are there. You can have your kind of confidence level. If data loss is like 1%, then it's okay and stuff. But eventually you want the most accurate data, right? So why are we sacrificing 1% data if we can get 100%, right? So the other option is to have it sent through our transactional database actually. So we start streaming whatever logs coming into the database and start writing it to our data lake setup in the cloud. So we don't lose any data because whatever is written in our transactional data, it's written in our data lake setup, right? With the first one, you just have to trust the platform, right? Whether it's like 99% correct or like 98% correct or like 100% correct. You just have to trust it. You can do like benchmarking every week, whether your discrepancies gets bigger or decreasing, but you can never get 100%. So with this one, we're kind of leveraging what it's been there in our transactional database and just scale it up to the cloud, right? And then what, right? So before migration, we do a lot of research, lots of it, right? We start the migration starts in January, but the research actually we start like mid 2017 actually. So we explore a lot of architecture. We explore a lot of cloud providers. We explore a lot of programming languages, right? And to come up with this solution is actually depending on your roadmap, right? Your technology company, your company's technology roadmap. So for certain company, they will have this kind of restrictions about regulations and stuff. They should have it on premise, or they have this relationship with other cloud provider, so they have to use like Amazon and stuff, because lots of their current ecosystem resides there in the Amazon ecosystem, right? So with all these concerns and stuff, we come up with our benchmarking tool, which we test out different cloud. The ones that we tested is AWS. We test in Alibaba Cloud as well, and we test in Azure as well, but not too deep on Azure, because we know that it's not the route we are going to take, because we don't have data there. We don't have any services in Azure, so why should we consider Azure in the first place, right? We do have some Amazon services set up at the time we are doing the testing, but what we see is that, I mean, Amazon can have all these different solutions to our problem, but then again, who will integrate to our web behavior data, right? Where you cannot, have it on the Amazon. Okay, and then we start building our roadmap. So for 2018, what we are going to achieve, in how many steps do we want to achieve them? So we break down into smaller, achievable, phases where we can get results every month, where we can see progress every day. Then we start building our, roadmap on that. Okay, during the migration, we have this weekly planning. So when we start, we just see through our existing data warehouse, where we have like 1,000 tables and stuff, with close to maybe double the number about the sources. And then how do we prioritize, right? That's the most important thing. Same thing when I started, doing data warehouse, so we start with the most important one, right? What report are being used by the management? That's the most important part, right? What reports are, related to our key operations metric? That's the most important one. And then we start to break down what table, should we migrate to get this number. So for example, if I have a number of users as our KPIs, then how do I get the number of users? What table should I take it from? And how is the data lineage of it, right? And then we start discovering, if you build every pipelines with different codes and stuff, it takes a lot of effort. Then we start building our template. So for every job that we make, it's totally, maybe not totally automated. It's like 50% automation. So we just have to configure which table we want to connect, what columns we want to map it out to, and then basically the template works for you. You just define the connections and stuff, and it will automatically create the table for you, and then start identifying the schemas of the table and stuff. So we don't have to write it ourselves. Imagine if I have like 1,000 table, I have to create this script for every table, create table as 10 columns, 20 columns, 50 columns, like maybe some tables takes like 150 columns and stuff, with all the data types that I have to type in. Then it's not a problem, right? So we did a lot of testing on the cycle, and this is our challenge, right? And how we address it. So previously we don't have a dedicated team. So basically in BI we did end-to-end, right? So at the first data that is coming into our landing database, do ETLs, do data transformation, data manipulations, writing the scheduling stuff, and you build your visualization on top of it, right? So for a person to do to create a dashboard, they have to create the ETL themselves, right? Takes a lot of time and a lot of effort, but it's the best thing that we can do at that time, right? Now that we have the luxury of more people coming in, more experienced people, then we start segregating the jobs, right? This team works with the ETL stuff. This team works with the visualization, because that's how we split it, right? And prior to this, we don't have BigQuery experience. The closest thing with Google BigQuery experience is actually Google Analytics, right? So we start exploring Google BigQuery apparently when we start thinking that our Google Analytics, as a tool isn't enough. What if we want to create our own metrics, right? We don't even want to use Google Analytics kind of definition for visitors. We don't want to use their definition for conversion rates. So we start exploring, is there a way to do it? Then we found that Google Analytics can export data to BigQuery, right? And then we start, leveraging what data is there, and start building our own definitions to our certain metrics. But the regular ones, we still use Google Analytics, of course. And our BI team doesn't have coding experience, so we don't come from software engineering background. So most of us is analysts or of BI backgrounds, right? When you have all these tools, ETL tools, because you can drag and drop and stuff, right? So we don't need coding, right? So when we move to GCP, actually we have to start writing our own codes, because we found that writing codes is more flexible, and writing codes is kind of faster actually to do the processing, because all these tools isn't optimized for Google Cloud Platform, right? So for example, if you use ETL tools from IBM, for example, right? Data Stage, so they works best with IBM platform. Do they work best with Google platform? No, right? Or other tools like Informatica, right? Power Center. Yeah, it might not work for Google Cloud Platform, and it is another cost to pay, right, for these tools. So we choose to, have this coding with our minimal coding experience, like almost zero actually, and start exploring. We're comfortable with SQL, right? We can write the most advanced SQL you will ever see. We can optimize this 1 hour query to 15 minutes query by leveraging, optimizing the structure of the query and stuff. But we don't have the coding experience, right? So what we did was to make an official team, right? So this team is a dedicated team to do this migration stuff, and trust them. That's where for me, it's the most important thing, right? So we build the team and we trust them, right? We know that they have zero experience, but we start building the team. So we get a lot of help from the GCP team, which is Gaurav, which helped us with the architecture. And how do we do so far? So we just started this month, this year, right? So we have built up to 500 jobs in small time, and actually we have 100 of them is scheduled now. So we're moving very fast, and we get results every day. Okay, we try out the 3 different languages. So we found that the best part for us is actually the last one. So we build the jobs, a few hundred jobs with Python, and then we write it in Java, and then we write it in Scala, right? So it's painful kind of exercise, but that's we have to do. Okay, we have 5 people in our team right now doing all these 500 jobs and stuff. So this is what we learned, right? You should do a lot of research before you start choosing what platform, right? So we do a lot of it, and then be agile about it, right? When you see there's a limitation of the languages, for example, start change your language. Maybe some language works best, some language doesn't. So you have to be agile about it, right? And create a template about it. So when you start, find a solution to your problem, then automate them, right? You don't want anyone to have the same problem as you. Okay, and actually the most important thing is to break down complexity, right? So if you have 1,000 steps, you break down to smaller steps when you get results every 2 days, or you get results every day. So you can see progress and you can feel good about it, right? Rather than you want this results happening in by the end of the year, but you cannot see how are we progressing each day. It's very hard for us actually. So that's the one thing that will help you guys when you start doing this kind of project, right? And when using BigQuery, I think this is the one thing unique to BigQuery. So use legacy SQL. Don't use legacy SQL. So there's 2 kind of SQL languages. Which is standard SQL and legacy SQL. And we found that standard SQL is faster than the other. So I think initially we write our SQL languages in legacy, and then we have to change it all, right? Doing all these jobs again. And for 2018, actually, we are moving to self-service analytics. So in people part, we'll start delivering data to the business users, right? Not only part of the request, but they get touched to the data, right? So by leveraging our BI tools, we can get them to access the data, play it with themselves. Of course, maybe some analysis need a more complex algorithms and stuff, but doing summation, doing aggregation, they should be able to do it themselves, right? So our goal for 2018 actually is self-service analytics, and we want to build data governance on top of it. It's like building process on top of data, right? And then I think on technology part, there is this data warehouse migration. We move our Tableau to the cloud as well. Previously it's on-premise, and then why not we move it to Google Cloud as well, because the data is there anyway, right? So we start moving our Tableau to the cloud as well. I think the last part is actually what interests us the most, because we want when I start building data warehouse, so I start small, right? Maybe what do you call it, a bottom up, right? You start picking these business lines or these modules and stuff, and then you start building vertically, right? When you join the data together and see how it's all sync up together, right? So for this year, actually we want something more, right? We start with data abstraction. So when we talk about orders in different business lines, they should talk about the same attributes, not about marketplace orders or digital goods orders or even ticketing system orders, right? When we start about abstracting, it's about the attributes that relates to the entity instead of the database, right? So I think this is what we are going to achieve in this year. Hopefully it works out, right? Thank you.
So my name is Gaurav, and I'm the solution engineer at Google, working with the cloud team based in Singapore. But I've been working for the Indonesian market for last 1 year. So today what we are going to discuss is about not data analytics, but we are going to look into a more specialized analytics, which is the streaming analytics. And we will be discussing streaming analytics using Apache Beam, so which is a kind of a new framework which was open sourced by Google 1.5 years back. And we'll also discuss about how we do streaming analytics using cloud data flow, and we'll take up an example. I'll show you some cool demos which I'm sure you guys will definitely like. Okay, so before even I begin, how many of you guys are from a data background or you are data engineers? Okay. Okay, maybe I should reframe my question. How many of you are programmers? Okay, so I like the audience. Okay, so what is Apache Beam? So have you guys seen this symbol anywhere? No, right? Okay, probably the next slide you will be able to identify some of the symbols. So what basically Apache Beam is, as I mentioned, Apache Beam was open sourced by Google in 1.5 years back, and it has been like it's basically the innovations which have been happening in Google for last 10 years in terms of distributed data processing. And you know, this basically expresses both batch and streaming pipeline. So if you would have listened to what Victor mentioned, Victor did use, you know, batch and stream quite a bit in his talk. So probably at least you guys have kind of a rough idea of what batch is. Batch is something which we do at some regular intervals, like maybe every hour, every day, every week, every month, something like that. And stream is something which is like an infinite, you know, ingestion or incoming messages, which doesn't have a defined boundary. So that's what is stream at a very high level. So traditionally people have been doing more of batch processing or batch analytics, but the value which you bring to your business is when you do stream analytics. And during today's talk we'll see what are the different types of streaming analytics which are the most common ones, and what are the different industries which are leveraging those streaming analytics. So Apache Beam, as I mentioned, open source by Google, it expresses both batch and stream pipelines using one model and one SDK. So ideally, if you are doing a batch processing and you're doing a stream processing, you would be using two different kind of frameworks, or different kind of languages, different kind of runtimes and things like that. And also with Apache Beam, it supports execution across different runtime environments. So you develop your code in one system and then you can run in multiple systems. So we'll see what are the different systems in which you can actually run your data pipelines. So let's talk about evolution of Apache Beam. So can you identify some of the ones? This was new for you guys, but the ones below might be like Hadoop, Spark. Okay, so in 2003, Google did release a white paper on MapReduce, and that changed the way we think about distributed data processing. But in Google, we kept innovating and we kept publishing, a lot of white papers. So the ones which you see at the top, these are kind of white papers which Google did publish over last 10 years. And these are nothing but kind of internal systems which are being used in Google for different products. Be it search, be it YouTube, be it calendar, be it Gmail, be it Google Photos. So using the white paper which Google released in 2003, Apache Hadoop was born, and then we had a set of different open source components which flourished over last 10 years. But as I mentioned, Google kept innovating, and in 2014 we developed which is something called as Cloud Data Flow, which is now open sourced. The SDK is open sourced by the name of Apache Beam. So I'll explain you what a SDK is and what a runtime is. It's very important to understand how you develop a pipeline and how you run a pipeline, or where you run a pipeline. So what Apache Beam does is that Apache Beam is trying to kind of bring all that innovation from the open source ecosystem and all the innovations which have been in Google in terms of distributed data processing. So today's agenda we'll discuss about how we express data pipelines in Apache Beam. Basically, what's the model behind Apache Beam? We'll discuss about Apache Beam's portability vision, and we'll see some of the streaming analytics use cases. And at the end, I'll show you a demo, which is basically an online retail e-commerce use case. Okay, so Apache Beam, if I have to kind of sum it up in one single slide, so it's like one model, and it has multiple modes. So basically you can do your batch processing and stream processing using the same model or using the same code, which even we'll see in the example later. It supports multiple languages. We support Java, we support Python. We have, since it's been open source, we have a lot of contributions from the open source community. People have developed they have developed the SDK in Scala. There is also development under Go for developing the SDK in Go and so on. And it supports multiple runners. So runners is basically, so you develop your code using the SDK, and in order to run that code, you need a runner. So basically the code which you develop using Apache Beam, you can either run it locally, or you can run it on Cloud Data Flow, which is the fully managed service on top of Google Cloud, or you can use Apache Flink, Apache Spark, or Apache Apex. So the same code which you develop using Apache Beam, be it for any mode, you can run on either of these things. So if you have an existing Spark cluster, or if you are already using Apache Apex, you can actually run that as it is without any change. So, so we'll take an example of, in order to make you guys understand what the Beam model is. So let's take a gaming example. I see a lot of people on phone now even, so I hope no one is playing a game now. So we have seen how games have evolved in last 10 years and how people are crazy. I have a lot of my fellow Googlers working in Korea and Japan, and they are like only working with gaming customers. So that's how huge the gaming platforms are. So in order to run through what Apache Beam model is, let's take a gaming example. So let's say somebody launched a game worldwide, and people are playing it across the world, and there are like teams being formed with specific individual, and each team kind of report their scores back. So this is the example we'll take and to understand the Beam model. So if you see this graph, right, on the x-axis you see something as event time, and on the y-axis you see something as processing time. And the ones which you see as the circles with numbers, these are nothing but the team scores. So basically what an event time is that the moment somebody submitted a score, a team submitted a score. So in this example, if you see the score 7, or maybe let's take the score 3. The score 3 was submitted or reached to our system at 12:07. And the moment it reached to our system, it got consumed and processed in the data pipeline. But there is a score which is 9, which was kind of submitted around 12:01, that actually landed in our system for processing after 12:08. So that's like a 7-second delay. And that's a very normal case. For example, someone might be playing a game in a subway, or in a flight, or subway, or in a flight, or somewhere which doesn't have a complete internet connectivity, and the moment he comes back online, the score kind of arrives in our system for processing. So this is kind of a late data, right? So in an ideal world, if everything goes fine, so whenever the data gets generated, it gets processed immediately. But that's not how the distributed systems behave. Distributed systems don't cooperate. So there are so many challenges when you kind of process data, and handling late data is one of the biggest challenges. So the Beam model basically revolves around 4 questions: what, where, when, and how. So basically the first question is what results are calculated. So what means basically your business logic, which is, do you want to do an aggregation, do you want to do a summation, do you want to run a machine learning model or a histogram and things like that. Where in event time means how the event time, which I showed to you in the last slide, relates to the data processing. When in processing time, so when in processing time is nothing but how does the data arrival time to our system affecting the results, which is the late data which we saw in the last slide. And the fourth is how do we handle that late data, which is the how. And we make sure that the results which we are calculating, they are correct, and they kind of incorporate the late data. So in order to answer these 4 questions, I'll show you some, okay. So this is like a sample snippet code basically. So the same example which we have taken is summing up the game scores of teams, right? So in this, the one which is in yellow, you see that's like getting scores for each and every team. That's our business logic. So that's the what part. What are we computing? We are doing an aggregation, right? This could be like anything. In our example case, it's like a simple aggregation. So ideally, if I have to aggregate everything, right? So I will just sum it up, But in this case, what happens is I need to wait for the entire data to arrive before even I aggregate. So I do my aggregation at the end of the day, assuming all the data which was generated like t-1 is already there. So this is like the classic batch processing, wherein we know that the data is there. The second question which we discussed were in event time. So the same business logic, which is summation, if you don't want to wait for the entire data computation to finish, we can actually slice the entire computation into specific time frames. So basically, if I want to calculate the results every minute, every hour, or every 2 hours, so I can do that by just using a simple windowing function, which is part of the SDK. So now what I'm doing is that I'm calculating the results every 2 minutes. So you can see that the sum, the game, the score of the teams are being calculated every 2 minutes. But again, in this case, we are still not emitting the results because we are still waiting for all the data to arrive. So this is again an example of batch processing. So if we keep waiting for the data to arrive, we will bring unnecessary latency to our system, right? As Victor was speaking about the business metrics, right? If I'm running a company, I want to know how my company is behaving every hour. I won't wait for a day to kind of my BI team to give me a report of what my growth is or what my monetization report is, right? Because I want to be competitive in the market, so I want to have the results in real time. I don't want to wait for a day, right? So in order to solve that problem, the model gives you something which is called as a watermark. So I'm sure some of you might have heard what a watermark is. So watermark is basically the system's best estimate of your data completion, and it's heuristic basically. So the system which is ingesting your data, it kind of predicts whether your data is complete or not. That is what is a watermark basically. So when we involve watermark, when we use that, and then we again recalculate the same results for every 2 minutes, the green line which you see, that is what is a watermark. So this is what the system kind of identifies by itself. I mean, the Apache Beam model identifies by itself. But in this case, you can see that it's not computing, it's not adding 9, because the system estimated that the first window is correct. I mean, the data has arrived, but in reality, the data hasn't arrived. So we still have a problem. So how do we solve this problem now? So in order to solve this problem, we include a more sophisticated trigger wherein we add this snippet in the code. By the way, don't get scared by seeing this. I'm using very minimal code, just trying to kind of explain you what's happening on the background. So by using this sophisticated trigger, what we are able to do is we are able to kind of identify whether the data is early, or the data is on time, or the data is late. So in the first scenario, when we had a late score of 9, what the system will do is the system will recalculate the result. So the first time it will calculate 5, and the next time when it sees that the data has come for that particular event time, it will kind of sum it back to the original result. So in this way, what we are able to achieve is the stream processing. So this is what is a stream processing, right? You were able to handle the late data, and you are also computing you're applying your business logic in real time. And by this, we are emitting the results every 2 minutes. So to sum it up, like the 4 questions which we were trying to answer, so the first one and the second one is mostly batch, and the third and fourth one is streaming and accumulation. So that's how you do batch and stream processing using the same model on top of Apache Beam. So let's talk about the Beam's vision for portability. So basically, like my last 9.5 years of experience with open source, I have seen technology changing so rapidly. I still remember my days, which was 9 years back, when I used to just search for Apache Hadoop, and I used to get only one official Apache documentation. And now when you just type Hadoop, you get like 10,000 results to kind of learn and get to know what that system is actually. So what Beam's vision is to kind of expose the model via different SDK. So the 4 questions which we saw a while back, that comprises the Beam model, and we want the developers to pick their own choice of SDK. So if you're a Java developer, if you're a Python developer, if you're a Go developer, if you're a Scala developer, just use whatever language you want to. The Beam model will kind of take care of identifying your code and run it across different runners. So you have a choice of SDK, you have a choice of runners. And of course, when you run it on Google Cloud using Google Cloud Dataflow, it kind of takes care of a lot of things, which is kind of rebalancing. It kind of shards your processing. There's like tons of benefits when you run it on Google Cloud. So where we are right now with Apache Beam, so our latest release is 2.3. We have a full Java SDK support for both stream and batch. The Python SDK support is right now for batch. We released streaming in alpha right now. And Spotify, who is one of our customers, extensively using Apache Beam and Cloud Dataflow, they have released their own version of Scala SDK on top of Apache Beam. So you can develop your code, you can develop your pipeline using Java and Python, and you have the flexibility to run it anywhere. on all of these different runners. So, so basically what Beam is doing, if you remember the second slide which I showed to you, is trying to bring all the distributed data processing under one single umbrella, and it's trying to bring all the good things from all different sides, from the open source side and also from the latest innovation which has been a result of Apache Beam. Okay, let's talk about some of the streaming analytics use cases. So, as I mentioned to you guys a while back, nobody wants to wait. If I'm sure most of you guys over here might be using YouTube and Spotify, right? And the moment you search for a video, the next time you see a different recommendation result, and it's basically catered to a specific individual based on what he or she likes to view. If I would had been shown the recommendations after a day, probably I won't be even bother to visit that same website, right? And this applies to all different industries, be it online retail, ad tech, media, or IoT. So that's how the stream processing or the real-time processing is important, because you want to make business decisions quickly. You don't want to wait for a day or even for a half day, because we know how competitive the market is. For each and every, Gojek is our customer, is our Google Cloud customer, and we are seeing how we have like Uber, we have Grab, we have Gojek, and all these different ride-hailing apps competing against each other. So you have to be innovative, you have to be fast, and you can be doing that if you're doing stream processing. So, so basically, if you remember some of the slides from Victor's session, he kind of showed you some architectures. Of course, his diagrams were much more better than mine. Mine are very boring. So, but still, so whenever you're doing a stream analytics, right, the first step is the ingestion. So you will be ingesting data, or you'll be consuming data from your applications. Your applications can be web-based, it can be mobile-based, and you might have like other systems like devices and things like that. So you will be consuming all that data into a messaging system. So Cloud PubSub is the messaging system in Google Cloud Platform. If you are aware of what Kafka is, what MQTT is, Cloud PubSub is very similar to Kafka and MQTT. It's like a messaging service. The moment you send a message, Cloud PubSub captures that message and gives back to the system to process it. Cloud Data Flow runs on top of Apache Beam, which is the SDK, using which you can do both your batch and stream processing. And to write your results back, you will be writing in your data warehouse, which is BigQuery, or you would be, consuming that data in some of your machine learning models. So this is like a very high level, architecture of what stream and batch analytics looks like. Okay, so okay, let's take an example. I'll show you a demo. So you have seen, of course, you guys use a lot of people nowadays do a lot of online shopping rather than visiting stores, and we find people always looking at their phones, comparing deals across different websites, looking at feedbacks of products which have been bought by previous customers. So this example, what it does is it kind of analyzes the customer feedback. So you have this shows like moisturizers. I'm sure females might be excited by hearing moisturizers, but so this kind of talks about like the different kind of moisturizers, and for each and every moisturizer there has been a feedback given by users who have bought it. So what we want to understand is we want to consume all that feedback, and we want to understand whether the feedback is good or the feedback is bad. Basically what we are trying to do is we are trying to do sentiment analysis on top of the customer feedback, and we'll see how we can do that using Cloud Data Flow and Apache Beam. So this is like 2 of the sample comments which have been given for the same product. So let's say if you read the first one, which says, I found excellent reviews for this product and I decided to give it a try, since all moisturizers I've used in the past didn't give me the results. This moisturizer feels amazing when applying. So if you just read this, right, the first sense which you get is that this feedback is positive. I mean, so if people are looking at this feedback, probably they will be kind of more positive in buying that product. And the second feedback which you read is again for the same product but posted by someone else who didn't like it, right? I mean, the moisturizer is totally useless, it has a horrible smell. So this seems that the person who kind of used it, he's like really, really angry. So most of the times, just by looking at the comments, we can identify whether it's positive or negative. But imagine I have 1 million products, right? And for each and every product, if I have at least 50 reviews, so I have like 50 million reviews to analyze. So I can't have someone to sit and look at all these 50 million reviews and say, oh yeah, this is positive, this is negative. I definitely need a system to kind of consume this feedback and tell me whether this feedback is positive or this feedback is negative. So how do we do that basically? So we can analyze the feedbacks in real time. As people are submitting feedbacks for the products, we consume all that information in real time using our messaging service and using Cloud Data Flow, which is our streaming and batch ETL processing system. We process that and store it in BigQuery. We also might have historical feedbacks which might be sitting in some storage system, which in case of Google Cloud is cloud storage. And we can do both batch and stream using the same SDK and the same runner, which is Cloud Data Flow. So let's go back and see the example. Okay, I don't know how much visible this is. Okay, again, don't get scared by seeing this. Maybe after some time you guys also might be doing the same thing. Okay, so basically what this is basically a code which has been written to both batch and stream processing. And when I run this pipeline, the same code I can run in both batch and stream fashion. So basically, I'm not sure why this, I cannot, okay, I cannot further enlarge this. So basically what I'll do is I'll just run this. Okay, so I just ran this, I just ran a streaming pipeline. This is my code in which is running on top of Cloud Data Flow, right? So now what I'll do is I'll publish an event, I'll publish a feedback in real time, and I'll see how the system processes it. I mean, the Cloud Data Flow processes it, and then it stores back the results in Google BigQuery. So okay, so I'm not sure how familiar most of you guys are with the Google Cloud Console, but this is how the Google Cloud Platform Console looks like. On the left hand side, you have all different kind of services related to infrastructure, big data, machine learning, storage, and all that. So we have something over here which is the Cloud Data Flow, to which we just submitted a streaming pipeline. So you can see that I just submitted a streaming pipeline. So what does this streaming pipeline is doing? So as I mentioned, I'm just trying to analyze the customer feedback. So this is basically doing sentiment analysis using Google Cloud natural language processing. So there are like various APIs using which you can do sentiment analysis, and NLP API is one of those, right? So if you see this, the first thing which is doing is reading from an unbounded source, which is cloud pub/sub, and it is parsing that raw input, and then it is kind of indexing that input and applying NLP to that, and the output I'm writing it to 3 different BigQuery tables. So let's do one thing. Let's take a sample feedback. Okay, so this is one of the feedback I saw at one of the products in Tokopedia website. So let's take that as an example. And let's see what does the system says about it. I mean, just by reading this, seems like the user has been pretty happy, using Tokopedia and its whatever product he bought. Okay, so in order to publish this message, I have created topic in pub/sub. So topic is like for feedback, you created a physical topic to which you will be publishing the messages. Okay, so I just published the message. Now let's look at the pipeline. Okay, so as soon as I publish this event, you can see it's still showing elements not added. So the system will kind of consume that message which I just published, and then it will run through. So you can see it just identified that message. This is the size of the message, and you can see these are the steps. So and it even wrote back to the BigQuery tables. So I have created a separate table in BigQuery just to store the sentiment analysis results. Now let's go back to BigQuery. This is how Google BigQuery looks like. I mean, the UI is not very fancy, it's very simple. Okay, so I have a table called sentiment to which the result would be written back. So I'm just trying to query and see whether the result has been processed or not. Okay, so you can see how quick it is. This is the message which I had kind of published, and you can see that this got processed. Now in order to okay, let me okay, so what's cool about BigQuery is that you get all your output as a JSON response as well. So you can see this is the text. This was the feedback given by the customer, right? And what I have been doing is I have been trying to extract multiple things out of this feedback. And you can see in my pipeline I calculated something which has a sentiment total score. So a lower sentiment total score reflects that the feedback is positive. I also have like certain fields like sentiment surprise, sentiment positive, sentiment negative, sentiment unsafe, and things like that. Right. So this is how you can consume all these feedbacks in real time and process it, and then you can visualize using BigQuery. So let's say if the management wants to know how the products are performing for their e-commerce platform, they can have this pipeline consuming all the feedbacks in real time from customers, and they can have a dashboard which can be running on top of BigQuery, showing them feedback. I mean, the sentiment analysis of all different kind of products, which are there in their e-commerce platform. Okay, so the same code I can also run it in batch mode. So in order to run it in batch mode, I just need to change the parameters and run it in batch mode without changing anything in the code. So that's how flexible it is. You don't need to learn a different programming. You don't need to learn a different framework to do batch processing and a different framework for stream processing. We do have tools in Google Cloud using which you can avoid writing code, and you can do all the data transformation and crunching just by using the web interface, which is called as Cloud Data Prep. Okay, so let's go back to our slide. So this is what we did, and this is what we did in the pipeline. right? Okay, so so what Apache Beam does is that it solves your data ingestion problem, it solves your data processing problem, and it also solves your writing data back to your storage system. So all of these can be done just by using Apache Beam and Cloud Data Flow, right? And these were the different steps which were performed as part of the pipeline which you guys just saw in the demo, right? So before I end, probably I have a question for you guys. So I'm sure most of you guys can see this query, right? So there is a table in BigQuery which is having 100 billion rows, right? And what this query is trying to do is it's trying to kind of do some data crunching based on the regular expression from that table, which is having 100 billion rows. And BigQuery is intelligent enough in identifying that when I run this query, this is going to process 4 terabytes of data. Now you guys need to tell me, or you guys need to guess, how much time will BigQuery take to process 4 terabytes of data? I mean, any wild guesses are fine. Sorry? 1 second? 5 seconds? I think that's a very high expectation. 60? Okay. Sorry? 30 minutes. I think that's a very bad expectation. Okay, let's run this query. So I'm on Tokopedia's guest network. I'm not on a Google network. So let's see how much time this query takes. Ideally, it is able to crunch 4 terabytes of data in 30 to 35 seconds. If you are in a proper network, let's see how much time does it take now. Okay, so it was able to crunch 4 terabytes of data in 33.9 seconds. And you can see the results back. And to do all of this, the only thing which you had to do is just run a query. And you don't worry about what's happening on the background, right? That's what Google BigQuery is. With that, thank you so much, and I hope the session was useful. And I had a last slide as well. Yeah, okay, this one. So we have a Google Cloud developer community in Jakarta, and we are very soon going to open chapters across different cities in Indonesia. So please join this community, because we will be organizing series of meetups and series of events. So if you want to learn more about the technology, different implementations, customers speaking at different events, you should be part of this community. Yeah, thank you so much, guys.